Today we're going to be discussing how to solve radical equations. Everything we've done in the previous sections have focused on radical expressions where there was no equation sign. But now we're going to talk about how to solve radical equations. And we're going to focus on solving square root equations, solving other radical equations, and solving an equation with two radicals. So the first thing we're going to look at is how to solve square root equations. And the key thing is that a radical equation is an equation in which the variable that we're solving for is in the radicand, or it's the variable with a rational exponent. We have to be able to get the variable out of the radicand in order to be able to solve it. So let's look at our first example. And our first example here is 3 plus the square root of 2x minus 3 equals 8. Okay? Now, the key when doing these types of equations is recognizing what we're trying to solve for. We're trying to solve for x, but x is underneath the square root sign. So it's not that easy to isolate. So what are the steps in doing this? Well, step one is we need to isolate the radical expression. So in this case, in order to isolate the radical expression, we have to subtract 3 from both sides. And we get the square root of 2x minus 3 equals 5. All right. Now that we've isolated the radical, we have to try to get rid of the radical. And to do so, you're going to raise both sides of the equation to the index number to rid of the radical. So in this case, we're taking the square root of 2x minus 3. So what is the index number? The index number is 2. So we're going to raise both sides to the second power. By doing that, we now get 2x minus 3 equals 25. By raising to the index number, we have now gotten rid of the radical. And so our last step here is going to be solve for the unknown, which in this case is x. So we're going to add 3 to both sides, and we get 2x equals 28, x equals 14. Now, before you can say that that is absolutely the solution, you need to check for extraneous solutions. And we do that by plugging it back into the original equation. So 3 plus the square root of 2 times 14, because that's what we got as our solution, minus 3 equals 8. So we get 3 plus the square root of 25 equals 8. So 3 plus 5 equals 8. That is a true statement. So this is the solution. Okay? All right. I'd like you to do one on your own, please. One on your own. All right. Go ahead and solve the square root of 4x plus 1 minus 5 equals 0. So if you did this problem correctly, the first thing you would have done is added 5 to both sides and get the square root of 4x plus 1 equals 5. Then you would square both sides because the index number is 2. and get 4x plus 1 equals 25. You would solve now. By subtracting 1 from both sides and getting 4x equals 24, and then dividing by 4 and getting x equals 6. Now the final step would be to check by plugging it into the original equation. When I did that, it worked, and so our answer is correct. X equals 6. So now that we've solved square root equations, we need to solve other types of radical equations. And this could be third root, fourth root, fifth root. It could also be radical equations written with their rational exponent. And so we need to review what a rational exponent is. And a rational exponent is an exponent in fractional form. So a over n. What does that rational exponent represent? Well, n represents the index number on a radical, and a represents the exponent on the radicand. So for example, the third root of x plus 1 squared can be rewritten as x plus 1 to the 2/3. Okay? Or if you had the fourth root of x, which means that there's an exponent of 1, you could rewrite this as x to the 1/4. Go ahead and rewrite the following radical in rational exponent form. The fifth root of a squared. Hopefully you wrote it as a to the 2/5. It's the exponent on the radicand over the index number. Let's do one more, and let's have you try this one. The third root of a to the 4th, b to the 5th. Well, for this one, this could be rewritten as the third root of a to the 4th, b to the 5th, all raised to the first power, which would then be rewritten as a to the 4th, b to the 5th, raised to the 1/3. Excellent. So why we introduce that is because you might be asked to solve radical equations when they're written in rational exponent form. For example, a problem like this. 3 times x plus 1 raised to the 2/3 equals 12. When you see a rational exponent now, you automatically think that means it's a radical. We've just rewritten it in a different manner. So we have to treat it the same way. We still have to first isolate the radical. And in this case, the radical is the term with the rational exponent. So the first thing we're going to do is divide by 3 here. And we get x plus 1 to the 2/3 equals 4. Now, in this case, if you're ever given a problem as such, when solving equations in this form, you're going to want to raise each side of the equation to the power n over a, the reciprocal of your rational exponent. So that will be step 2. Raise each side of the equation to the reciprocal of the rational exponent. So in this case, we're going to raise both sides to the 3/2. By doing that, these exponents will cancel out, and we'll get x plus 1 raised, x plus 1 equals 4 raised to the 3/2. Now 4 raised to the 3/2 can be plugged into our calculator. and you get x plus 1 equals 8. And now step 3 is we just solve for the unknown. Minus 1 on both sides, x equals 7. Now, the key to this is you need to check your solution. Okay, once again, check by plugging into the original equation. So 3 times 7 plus 1 to the 2/3, does that equal 12? Okay. In this case, if you plugged it into your calculator, you get 12 equals 12. So that is correct. So that is one of the solutions. Okay? Now, the other thing is that something very important happens here. If n or a, which means that if either our exponent on the radicand or our index number are even, then what it equals must also be negative. So right here, not only does x plus 1 equal 8, but because our a value is even, x plus 1 also equals negative 8. So we also get x equals negative 9. When we plug in negative 9 to check, it works out as well. So once again, if either of the values in the rational exponent are even, once you get down to this step, you need to make sure that you take into account the negative value as well. Let's do another example of this together. So our example here is 2 times x plus 3 to the 2/3 equals 8. So our first step is to isolate our radical, which in this case is here because we have a rational exponent. So we're going to isolate that by dividing both sides by 2. Okay? And we get x plus 3 to the 2/3 equals 4. Now, what are we going to raise both sides to? We should raise both sides to the 3/2. And we get x plus 3 equals 8. Now we need to check whether either of our values in the rational exponent, are even. 2 is an even number. So, do we have a second equation to solve? We sure do. Our second equation is going to be x plus 3 equals negative 8. Go ahead now and solve the rest of this problem. If we solved both of these equations, we would get solutions of x equals 5 and x equals negative 11. And if I plugged both of them into our original equation, they would work out as solutions. So the last thing we're going to talk about is solving an equation that involves more than one radical. All right? And the steps to doing this are that you want to isolate one radical first, eliminate that radical, isolate the second radical, solve, and check for extraneous solutions. So let's look at an example like this. So our first example is going to be the square root of 2x plus 1 minus the square root of x equals 1. So here we have two radicals. So we're going to try to isolate one. And I'm going to isolate one by adding plus x, the square root of x, to the other side. I'm going to try to isolate